Hi everyone, this is Pavitra, working as an assistant professor in Sri Muthukumaran Institute of Technology in Biomedical Department. I'm going to give lecture on BM 3401 Signal Processing. Regulation is 2021. Here, these are the course objectives of this subject. Students can able to understand the continuous and discrete time signals and systems, and also know about the analysis of linear time invariant systems using Laplace and Z transforms, and also to represent the signal in frequency domain using fast Fourier transform, and also to gain knowledge about the design of IAR and FIR filters. At end of this course, students can able to classifies the continuous and discrete time signals and also the systems, and also to analyze the signals in both continuous and discrete time, and also to apply discrete Fourier transform for the analysis of digital signals and systems, and can able to design IAR filter to process in the real world signals, and able to design FIR filters in real world signals. Here, these are the 5 units of BM 3402. Unit 1 will be fundamentals of signals and systems, and unit 2 is analysis of linear time invariant systems, and unit 3 is discrete Fourier transform, and fourth unit will be infinite impulse response filters, that is IAR filters, and finally finite impulse response filter and multi-rate signal processing also, and also the applications of signal processing we can see in this unit. Here now we will see the unit 1 fundamentals of signals and system. First we have to know about the what is signal. Signal is a information which carries signal is a function which carries information by means of amplitude, frequency and phase. It is a representation of physical quantities like sound, temperature, intensity, pressure, and also signals, analog signals, which will be varies with respect to the time, or it is also independent or dependent variable. Generally, signal can be represented as x of t equal to a sine of omega t plus phi. Here a will be the amplitude and omega will be replaced by 2 pi f. Here f will be the frequency of the signal, and also we can represent f as a 1 by time period, and phi is the phase angle. Omega is the angular frequency, that is omega equal to 2 pi f. This is generally analog signal can be represented like this. In x-axis time will be represented and y-axis amplitude will be represented. Here signal with different phases, amplitudes and frequencies. Here first signal with 0 phase shift, and here this is 90-degree phase shift, and this signal is 180-degree phase shift, that is phi phase shift signal. And next this one is amplitudes of the signals. First one is higher amplitude signal, and here is the lower amplitude signal. Here this is the high frequency signal, and this one is low frequency signal. This is the signal with different phases and also amplitudes and frequencies representation. Next, types of the signals. With respect to dimensions, we can classify signals as one dimensional signal, 2D signal and 3D signal. If the signal is function of only one variable, then the signal is called as one-dimensional signal. If signal values varies with respect to only one variable, that is anything like height, length, like that. For examples, 1D signals are audio signals, biomedical signals. Biomedical signals includes ECG, EEG, and temperature signals, in which signal is function of only time. This is the one-dimensional signal representation. Here is the ECG signal, here is the audio signal, and this is the different ranges of the signals. Next type is 2D signal. If the signal function varies with respect to two variables, then it is known as two-dimensional signal. One dimensional will be in x-axis and another one will be as in y-axis. For example, we can say image is a 2D signal. And next type is three-dimensional signal. If the signal is a function of three variables, that is signal will be vary with respect to three variables, then it is called three-dimensional signal. For example, we can say video signal as is the 3D signal. X and Y will be 2D signal. If it is added with t with respect to time, then it is called three-dimensional signal, X, Y, T. Next one is classification of signals based on the nature of the signal. Here we will have two types of signals: continuous time signal or analog signal, digital signal or discrete time signal. Continuous time signal is continuously varies with respect to time, then it is called continuous time signal or analog signal. It contains only infinite set of values. This is continuous time signal. It will be in waveform. And next one is digital signal. If the signal contains only two values, then it is called digital signal. The two values will be zeros and ones. Discrete time signal is nothing but discrete set of values will be changed with respect to time, then it will be called as discrete time signal. It contains finite set of values when compared to the infinite set values of the continuous time signal. Sampling process will convert the continuous time signal into the discrete time signal. This is the discrete time signal representation. Now we will see the representation of discrete time signal. There are many kind of representation of the signals. Here we will see four kind of representation of signal. First one is graphical representation of the signal. For x values, there will be stripe representation in this graphical representation of the signal. Discrete time signal is represented as x of n, and continuous time signal will be represented as x of t. Here x of n will be 1 for n equal to 1 and 3, 4 for n equal to 2, 0 otherwise. We can represent this signal in tabular representation also. This is the functional representation and this is the tabular representation. We will divide like this and give values. Here x of n values will be under and n values will be in upper. This is the sequence representation of the signal. We will indicate it by arrow mark. And finally, the mathematical representation of discrete time signal will be x of n equal to x of t. T is equal to n of t. Basic elementary functions of the signals will be followed. First one is unit step function. Unit step function is denoted by u of t. It is defined as u of t equal to 1 when t is greater than or equal to 0. 0 when t is less than or equal to 0. Here it is will be in the 1 amplitude. This is a straight line. Unit step function will be in straight line with amplitude of 1. This is the best test signal for any kind of systems. Area under the unit step function will be unity. And next signal function is unit impulse function. It is represented as delta of t, and delta of t will be 0 for t is not equal to 0. If t is equal to 0, then delta of t will be infinite. Here impulse function will be represented like this. For one amplitude, delta function will be like this. Delta function is a differentiation of step function. So we can derive impulse function from the unit step function also. Likewise, delta of t equal to du of t by dt. This is the signal representation of impulse function. Next one is ramp signal. Ramp signal is denoted by r of t, and it is defined as if t is greater than or equal to 0, r of t will be t. Otherwise, it will be 0. It is the integration of unit step signal. Impulse will be the differentiation of unit step signal, and ramp will be the integration of the unit step signal. Area under unit ramp is also unity. U of t equal to dr of t by dt. We can derive the unit step signal from the differentiation of ramp signal. Next one is signum function. Signum function will be represented as sgn of t. Here three values will be there: positive, negative and 0. For positive one is t is greater than 0. Minus 1 will be t less than 0. 0 will be if t is equal to 0. This is the representation of signum function. For positive 1, signum function will be straight line in the positive axis. For negative 1, signum function will be in the negative axis. For 0, it will be in the 0 line. Now next one is exponential signal. Exponential signal is in the form of x of t equal to e a power t. The shape of the exponential can be defined by a. There is three cases in this exponential signal. When a is equal to 0, when we substitute a value is 0, e power 0 will be 1. So the signal will be in the unit 1 amplitude. The second case is when we give a less than 0, that is negative value, then x of t equal to e power minus at. That will be in the negative phase, then it is a decaying exponential signal. And third one is if we give positive values, that is a greater than 0, x of t equal to e power at. This shape will be in the rising exponential, that is in the positive phase. And next is a rectangular signal. Here rectangular signal x of t is defined as a rectangle of r by t. Here a is the amplitude and this is the representation of rectangle signal. Time will be separated in negative and positive phase. T will be separated as T by 2 and T by 2. Here, for example, 4 rectangle R by 6. 4 is the amplitude value and 6 will be separated as 3 and 3. Minus 3 and plus 3. This is the rectangle representation of this signal value. And next one is triangular signal. The signal shape will be in the triangle shape. Like rectangle signal, here x of t is equal to a of 1 minus t by t. A is the amplitude and t is the time period. Here time period will be same as t. Not like rectangle signal, it will be same as t. If for example, if 5 will be the time period, for a negative phase it will be minus 5. For positive phase it will be plus 5. Amplitude will be A. And last one is sinusoidal signal. Sinusoidal signal x of t is represented as this sine wave. Here A is the positive amplitude and minus A is the negative amplitude and T naught is the time period. T naught is given by 2 pi by omega naught. Omega is the angular frequency. Already we know that. These are the basic types of signal in the signals. Thank you everyone. For more videos, please subscribe our YouTube channel, SMIT YouTube channel. Thanks for watching.